Okay, AP Stat, we have looked at a histogram for quantitative data. Now we're going to move on to the stem plot. So as you can see on this example, this represents answers to what is the fastest speed you have driven. And I have a stem plot all written out for you. I'm just going to explain to you how to read it, and then we're going to answer all of these questions about it. So the first thing I want you to notice with your stem plot, just like every graph, you've got to have a title. And then right under that, a stem plot will always have a key. So that explains to the reader how they're supposed to get numbers from it. So notice the key says 11, and then there's that line right there that represents this big line right here, and then a 0, and that means 110. So a stem plot is all based on place value. So since our smallest speed here is a 50, that's where my graph starts. So this is 50 miles per hour, this is 57 miles per hour, 60 miles per hour, 62, 65, 66, 67, you get the idea. So a nice thing about the stem plot, it automatically puts everything in order from least to greatest, so that's kind of cool. And if you'll notice here, we've got places for 5, 6, 7, 8, 9, 10, 11. Keep in mind though, let's say we had mileage in the 50s and the 60s, 70s, and the 80s, but let's say nobody had driven in the 90s, but I had people at 101, 105, and 110. So if that had been the case, then you wouldn't skip the 9. Because if you would have skipped the 9, then it would have changed your shape. Because a stem plot uses the actual data pieces to create the shape of the graph. And it looks just like a histogram would, just laying on its side. So just keep that in mind when we make one, that you do have to preserve that place in the lineup. All right, so let's see how we're going to read this stem plot. How many people answered 88 miles an hour? Well, here's the 80 right here, and I've got 88, 88, 88, so that'd be 3 people. Describe the shape of the distribution. Well, I would say this is approximately symmetric. Okay, what is the median speed? Well, we find the median based on where it is in the middle when we've got all the values in order from least to greatest, which a stem plot automatically lends itself to that. Well, there are 26 pieces of data, so that means that the middle is going to be actually 2 numbers. If it were an odd number, then I would have an exact middle number, but since I've got an even number, I'm just going to count half of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the 13th number and the 14th number get added together and divided by 2, which of course is 79. So that's your 79 right there. If I'd had 27 pieces of data, then I would just have taken the 14th piece from the beginning, and that would have given me my answer. Okay, so part D, we can easily find one measure of spread, and if we work a little harder, we can find another one. So tell me the name of the 2 measures and find them both. Well, from this data piece, we can easily find, it says which ones we can easily find. That means without doing calculations. So we're going to leave standard deviation out of this one. So the ones I'm going to use would be the range, and the range is really easy. I'm just going to take my largest data piece and subtract my smallest data piece from it, and so the range is 60. That's how my speeds range by 60. All right, the other one is going to be the IQR. Now, Q3 minus Q1 takes a little bit more work to find, because essentially what you have to do is you have to find the value in your data that marks your Q3 and your value in your data that marks Q1. Now, in a perfect world, I would have a really easy way to do this for you. But to illustrate it properly, which I want to do so that everybody understands it, I am going to write out all the data. Now, I'm just doing this to illustrate Q3 and Q1 for you. What would you do if you wanted to find those? You'd put it in Stemplot because it would be so much easier, because nobody wants to write all of these. And once I show you where it is and help you understand what it is, you wouldn't have to do this anyway. I'm just writing these out as an illustration to you because remember, I have to teach it to you. I can't just show it to you. Oh, did I have a fit with my 88s? I believe I did. Can't take me anywhere. I'm out of control. And of course I'm going to run out of room. For crying out loud. I'm okay, kids. Don't get up. So frustrating because now it's going to be harder for you to see it. Dadgummit. You know what? It's fine. Everything's fine. All right, babies. Essentially, what we're going to do is count in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, just bear with me here. I know what I'm doing. I'm leading y'all to this. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I want you to notice something. I've got a group of 6 here after 93. I've got a group of 6 here before 67. And I've got 2 groups of 6 between them. Q1, Q3. You with me? 50% of your data fits between Q1 and Q3. A quarter before, a quarter after. Quarter before, quarter after. That's how that works. Am I ever going to make you do that? Like write all that out? No, I'm not. Okay, let's make sure I did my math correctly. Oh, yay for us. Okay, so the IQR is 26. Was it a little more work? Absolutely, of course it was. Okay, so Part E, but that gives you kind of a visual understanding of what Q1 and Q3 would be. So if we compare this type of graph, so we're comparing the Stemplot to a histogram that we've looked at before, and we are giving one advantage, and I'm going to give you more than that, give one advantage and one disadvantage to the Stemplot over the histogram. Okay, well, if you'll think about a histogram would just have bins, okay? So if I were to take this and turn it over, all right, so that it looked like this, I would have a bin that would be 2 high at 50, and I would have a bin that would be 5 high at 60, and at 70, you get the idea, okay? So the bins are great to show you how many data pieces are in a certain range of values, but guess what happens? All of your pieces of data, your individual pieces, get lost. Because when I'm looking at a bin that starts with 60 and ends with 70, like this one right here, I can count how many pieces of data are between 60 and 70, but I don't know what they are. They could all be 63. They could be 63 and 64 and 61. I mean, I don't know. So a Stemplot does a nice job of preserving all of your data. Okay, so it preserves all your data. In a histogram, your data gets lost because it just gets shoved into a bin. So there you go. So it preserves all of your data, and I'm going to give you this one too, and it puts all in numerical order. which a histogram does that too, but if it doesn't preserve your data, who cares, right? All right, so you can see all your data, it preserves all your data, it puts all in numerical order so you can easily find your median, etc., etc. Now, one of the disadvantages of a stem plot is the fact that a stem plot is only really good for small data sets. Now, I want you to think about why. If you were writing this by hand, and a stem plot's pretty easy to, write out because you're just writing out the numbers after you put them in order, least to greatest. So you wouldn't want to do this though with 100 pieces of data. So that would be a nightmare. So a histogram works way better with a larger data set. So histograms are great for large, my handwriting has gotten horrible, for large data sets, and stem plots are only good for small data sets. So in our next example, this will help you create a stem plot. So I know, get ready for the fun.